Dear viewers, today I discuss part 3 of the topic arithmetic progression. In this part, I deal with properties of arithmetic progression and some questions related to the properties. Here are properties of arithmetic progression. The first property says if same fixed non-zero number is added to or subtracted from an arithmetic progression, the resulting sequence is also an AP. Let's understand this through an example. In this example, A, B, C, D, so on, it means alphabets in succession, is taken an arithmetic progression where the first term is A and the common difference is delta. Delta here is assumed as common difference. Now in the first example we find that a fixed value beta is added to each and every term of the given arithmetic progression, and the new sequence obtained is A plus beta, B plus beta, C plus beta, and D plus beta, and so on. And the property says that this new sequence obtained again is in AP, where the first term is A plus beta and the common difference is delta. Here we find that the first term changes but the common difference remains same. Let's observe the second example of this property. In this example, a fixed quantity beta is subtracted from each and every term of the given arithmetic progression, and the sequence of numbers obtained is A minus beta, B minus beta, C minus beta, and D minus beta. According to the property, this new sequence also is an AP, where the first term is A minus beta and the common difference is delta. So here too we find that the common difference remains unaltered. Overall, we find in this property that if a fixed non-zero number is added to or subtracted from each and every term of a given arithmetic progression, then the new sequence of numbers obtained again is in AP, and here the first term changes but the common difference remains same as of the original arithmetic progression. Here is the second property of arithmetic progression. The property says if each term of an AP is multiplied to or divided by a fixed non-zero number, then the new sequence obtained is also an AP. Let's understand this through some examples. The original AP is taken as A, B, C, D, E, F, so on, where the first term is A and the common difference assumed is delta. Now in this example we find that a fixed quantity beta is multiplied to each and every term of the original arithmetic progression, where the new sequence obtained is A beta, B beta, C beta, D beta, and so on. According to the property, this new sequence obtained again is in AP, where the first term is A beta and the common difference is delta into beta. Here we find that the first term changes, that is usual, and the common difference too changes here. And you can easily observe and understand why the common difference changes. Now let's observe another example where we find that each and every term of the original AP is divided by a non-zero number beta, and the new sequence of numbers obtained is A divided by beta, B divided by beta, C divided by beta, D divided by beta, and so on. And according to the property, this new sequence obtained again is in AP, where the first term is A divided by beta and the common difference is delta divided by beta. So here too we find that the common difference changes. So overall we find here that the terms of an AP is multiplied or divided by a fixed positive number, then the first term changes and the common difference changes as well. Here is the third property of an arithmetic progression. The property says if corresponding terms of two or more AP are added to one another or subtracted from one another, then the new sequence of numbers obtained is also an AP. Let's understand this through an example. For this example, we need more than one arithmetic progressions. So here, two arithmetic progressions are assumed. First one is A1, B1, C1, D1, E1 and so on, where the first term is A1 and the common difference is delta 1 assumed. Next one is A2, B2, C2, D2 and so on in AP, where the first term is A2 and the common difference is delta 2. Here in these two examples, we understand that delta 1 and delta 2 are the common difference assumed respectively in these two different arithmetic progressions. Let's check this step. Here a new sequence is there and its terms are A1 plus A2, B1 plus B2, C1 plus C2, D1 plus D2 and so on, where A1, B1, C1, D1 are the elements of the first arithmetic progression and A2, B2, C2, D2 so on are the elements of the second arithmetic progression. So according to the property, this new sequence obtained is also an AP where the first term is A1 plus A2 and the common difference is delta 1 plus delta 2. Let's observe another example of the same property. Here the elements are A1 minus A2, B1 minus B2, C1 minus C2, D1 minus D2 and so on. And according to the property, this new sequence is also an AP where the first term is A1 minus A2 and the common difference is delta 1 minus delta 2. So overall conclusion is a new sequence of numbers obtained by adding or subtracting corresponding terms of two or more arithmetic progression is also an arithmetic progression where the first term is different from the first terms given in the given AP and the common difference too are different. Here is the fourth property of an arithmetic progression. The statement says every equidistant terms taken from an AP forms a new sequence and that new sequence also is an AP. This we can understand through the example much better. In this example, as usual, one arithmetic progression is assumed and its terms are A, B, C, D, E, F, G, H and so on, where the first term is A and the common difference is delta and this is assumed. Let's observe the new sequence of numbers obtained here. The numbers are A, C, E, G onwards, and here we find that this sequence is obtained by taking every alternate values from the original arithmetic progression. And according to the property, this new sequence also is in AP, where the first term is A and the common difference is twice delta. And the same way, the difference between C and E also is twice delta, and the difference between E and G also is twice delta. So hence it is an AP with the first term A and the common difference twice delta. Let's now observe another example of the same property. And here we find that the new sequence of numbers obtained is the every third term of the given original arithmetic progression starting from the first term. Hence, its first term is A and the common difference is thrice delta. And you can easily understand why the common difference here is thrice delta. Similarly, the fourth example too is same as the first two according to the property. And here we find that new sequence obtained here with the terms C, G, K, O and so on, we find that these terms are taken from the original AP where every fourth term is taken, but not starting from the first term. It is starting from the value C. Hence, the new sequence obtained here is again in AP and its first term is C and the common difference is 4 times delta. Well, all the properties of arithmetic progression is over, and now we take some questions which are based on the properties. Here is the first question on properties of arithmetic progression. Question number 12. Given A, B and C are in arithmetic progression and show that B plus C, C plus A and A plus B are in arithmetic progression. Let's observe the first step towards solution, and here we find that A plus B plus C is subtracted from each term of the given AP, and according to the properties of proportion, this new sequence obtained, that is A minus the sum of A, B and C, B minus the sum of A, B and C, and C minus the sum of A, B and C are in AP. Observe the next step where each term is simplified and we get a new sequence, and that is minus of B plus C, minus of C plus A and minus of A plus B. Here you don't need any explanation. Observe the next step, and this next step is obtained by multiplying minus 1 to each term of the previous arithmetic progression. And according to the property, since I am multiplying a fixed value to each term of an AP, hence the new sequence obtained again is an AP, and this only we had to prove. Let's observe the other method of the same question. Here we find that minus 1 is multiplied to each and every terms of the given AP, and hence the new sequence obtained is minus A, minus B and minus C. Hence, according to the property, this new sequence containing terms minus A, minus B, minus C are in AP. In the next step, we find that A plus B plus C is added to each term of the AP obtained above. So hence, according to the property, this new sequence of numbers, that is sum of A, B and C minus A, sum of A, B, C minus B and sum of A, B, C minus C are in AP. And finally, by simplifying the previous step, we get the result B plus C plus A plus B are in AP, and this only was to be proved. Here is another question, question number 13, and this question too is completely based on properties of arithmetic progression, in which the question says, given a 1 by A, 1 by B and 1 by C are in AP, show that BC, CA and AB are in AP. The given part is 1 by A, 1 by B and 1 by C are in AP. The next sequence is obtained by multiplying ABC to each term of the given AP. So since ABC is multiplied to each term, so the new sequence obtained according to the properties of the progression is also an AP. And finally, by simplifying each term, we get the final result. In the first term, A gets cancelled. In the second term, B gets cancelled. In the third term, C gets cancelled. And the final result is BC, CA and AB are in AP. Here is another question on properties of arithmetic progression. The question says, if A, B and C are in AP, show that 1 divided by BC, 1 divided by CA and 1 divided by AB are in AP. Observe the first step towards solution. What I find here is, in the given AP, I divide each and every term by ABC. So according to the property, this new sequence obtained is also an AP. After simplifying each and every step, we get the new sequence 1 by BC, 1 by CA and 1 by AB are in AP, and hence BC raised to minus 1, CA raised to minus 1 and AB raised to minus 1 are in AP, and hence proved. Let's take another question, question number 15. The question says, if A, B and C are in AP, then show that A plus 1 by BC, B plus 1 by CA and C plus 1 by AB are in AP. Here, each term of the given AP is divided by ABC. Hence, according to the properties of AP, this new sequence, that is A divided by ABC, B divided by ABC and C divided by ABC are in AP. After simplifying that terms, we get the result, that is new sequence of numbers is 1 by BC, 1 by CA and 1 by AB. Hence this sequence is an AP. Here we find that ABC plus 1 is multiplied to each term of the previous sequence, and hence we get a new sequence, and according to the properties of AP, this sequence is an AP. During simplification of each term of the previous step, we get a new sequence, and that is ABC by BC plus 1 by BC, ABC by CA plus 1 by CA, and ABC by AB plus 1 by AB. Hence, these terms also are in AP. During further simplification of the previous step, we get finally terms as A plus 1 by BC, B plus 1 by CA, and C plus 1 by AB. And hence, this sequence of numbers is an AP, and this only was to be proved. Let's observe this important note. The statement says, it is not easy to decide what to add or subtract, multiply or divide to each term at each stage to get the required result. Let's take the question which we discussed just now and study what critical points are here. In the first step, we find that in the given AP, I divide each term by ABC. The next action is, in the terms obtained, we multiply ABC plus 1, and then the simplification goes on and we get the final result. But the problem here is that decision is not that easy. Hence, let's look for some tips so that easily we find out what to multiply or divide in the existing term of an AP to get the right result. Let's take what suggestion is given here so that we easily judge what to multiply or divide in the existing terms of AP so that the remaining term remains an AP and we move towards the correct path. Well, the first suggestion is, if we fail to understand what to add or subtract or divide or multiply in the existing terms of an AP so that the solution get the right order and we get the right answer, in that case you should start from bottom, and perhaps it would be easier for you to decide what constant value to be added, subtracted, multiplied or divided. And the second suggestion says that after completing that solution in reverse order, you rewrite it again in reverse order so that you get the solution in right order. Now we move to another question, and you observe this question, you'll find that this question is just the reverse of the previous question. And here I'll show you that how in this case what to multiply or divide or add or subtract looks very easy. I mean, it's very easy to guess. So let's see that question number 16, given if A plus 1 by BC, B plus 1 by CA and C plus 1 by AB are in AP, then show that A, B and C are in AP. The given part is very much clear, and it's very easy to judge here that in each term at first LCM has to be taken, and after taking LCM towards simplification of each term of the given AP, we find the new sequence, and that is ABC plus 1 whole divided by BC. Next, ABC plus 1 whole divided by CA, and the third term is ABC plus 1 whole divided by AB. So since it is a simplification only, so this new sequence also is an AP. And here it is very much clear that each and every term of an AP in the previous step has to be divided by ABC plus 1, and hence we get the simplified step 1 by BC, 1 by CA and 1 by AB. So since here we have simplified each step, so obviously the current step shown here is in AP. And now here too it's very easy to judge that each and every term of the AP obtained above has to be multiplied by ABC. So the next sequence we get ABC by BC, next ABC by CA, and the next one is ABC by AB. And hence, according to the properties of AP, we find that these three terms also are in AP. And now finally, in the first step, BC gets cancelled and A remains. In the second step, CA gets cancelled and B remains. And in the third step, AB gets cancelled and C remains. So hence A, B and C are in AP, and this only was to be proved. Hence here we complete the chapter arithmetic progression. But if you have any doubt in any question which is discussed in the video, or if you have any other questions taken from different places or different books, you can put to us and we'll have one special class on your doubt clearance. Thank you.